Amino acid chromatography. By the end of this video, you should be able to explain the method of chromatography, identify amino acids in a mixture, and interpret chromatograms. So, chromatography of amino acids. So, chromatography is a procedure that can be used to separate a mixture into its individual constituents. Chromatography relies on differences in the solubility of the different chemicals called solutes within a mixture. All chromatography techniques use two phases, the mobile phase and the stationary phase. The components in the mixture separate as the mobile phase travels over the stationary phase. Differences in the solubility of each component in the mobile phase which affect how far each component can travel. And those components with higher solubility will travel further than the others. This is because they spend more time in the mobile phase and are thus carried further up the paper than the less soluble components. Paper chromatography is one specific form of chromatography. In paper chromatography, the mobile phase is the solvent in which the sample molecules can move, which in paper chromatography is a liquid like water or ethanol. The stationary phase is the paper in paper chromatography is the chromatography paper. A spot of the mixture that you want to separate is placed on chromatography paper and left to dry. The chromatography paper is then suspended in a solvent. As the solvent travels up through the chromatography paper, the different components within the mixture begin to move up the paper at different speeds. Larger molecules move slower than smaller ones. This causes the original mixture to separate out into different spots or bands on the chromatography paper. This produces what is known as a chromatogram. So you can see here you've got the chromatography paper, you have your spot of ink, but you have a line drawn in pencil so it doesn't dissolve in the solvent. You've got a solvent here and the solvent moves up the chromatography paper and separates the solute out into different components. So this black ink has been separated into three substances. So there's three different inks or colours of ink. So using chromatography to separate a mixture of amino acids. Paper chromatography can be used to separate a mixture of amino acids. A spot of the unknown amino acid sample mixture is placed on a line at the bottom of the chromatography paper, and then spots of known standard solutions of different amino acids are then placed on the line beside the unknown sample spot. The chromatography paper is then suspended in a solvent. Each amino acid will be more or less soluble in the mobile phase than others and will therefore separate out of the mixture, travelling with the solvent at different times or distances from the line depending on their charge and their size. The unknown amino acids can then be identified by comparing and matching them with the chromatograms of the known standard solutions of different amino acids. If a spot from the amino acid sample mixture is at the same distance from the line as the spot from one of the known standard solutions, then the mixture must contain this amino acid. In order to view the spots from the different amino acids, it may be necessary to first dry the chromatography paper and then spray it with anhydrine solution. This chemical reacts with amino acid, producing an easily visible blue-violet colour. So, the first thing you would do is set up the chromatography paper as in the diagram. So you've got your unknown solution, your unknown amino acid solution there, spot, and then which has been dried out, and then you've got your three known standards, and then this is your chromatography paper, and then you've got your line drawn in pencil. Then you would lower the paper into a beaker with a suitable solvent, and you wait for the solvent to travel up the beaker, up the paper. Dry the chromatography paper and spray with an anhydrine solution and analyse the chromatogram. So this is what the original amino acid, the unknown one, is separated out into. And these are our known ones. So you've got lysine, that's alanine, that's methionine. So you can see here that it contains alanine and lysine, but it doesn't contain methionine. So it's always worth trying to appreciate why a certain practical technique is useful. An example of when chromatography would be used is if you have an unknown liquid and you have determined it contains protein using a bioret test. Chromatography will then show you which amino acids are present so you can better comprehend the possible uses or functions of the sample. And this could be useful in crime scene investigations or in detecting additives or spoilage in foods.